we're going to tackle problem 13.6. So I have some work started here, and basically we're going to have a graph, and they're going to ask us to do something with the area of an isosceles triangle where the given sides are x, and y, okay, and we're trying to find an area function with respect to x of that triangle. So, remembering that the area of a triangle is 1/2 the base times the height, I'm going to do some substitution in here, and I'm going to call this the base of the triangle, so y becomes my base, and h is somehow the height of the triangle right here. So I need something about that h. I also need to put y in terms of x. So they tell me that the perimeter is 12. So if I solve this equation for y, just by moving the x's over, I get y now in terms of x, and I can substitute that into my area formula, and that only leaves now the h, which again is going to be that right there. But in an isosceles triangle, if you take the height of that triangle, that thing is called an altitude. And now I have a right triangle with the hypotenuse, half the base, and the height as my right triangle. So here's my triangle again. I've got half of the base, I've got the height and the hypotenuse. I'm going to solve this for h. Also going to substitute in my expression for y from the perimeter equation, and I've got now 1/2 the base squared plus the height squared equals the hypotenuse squared. I'm going to solve this, forgetting those parentheses, I'm going to solve this for h, and here we go. I've got my h equals expression, which h equals the hypotenuse squared minus the leg squared, and take the square root of that. Now, normally I would want the plus or the minus, but I don't need the minus because I'm talking about a height here, so this isn't an algebraic thing, this is a physical distance thing, so I just need the plus. Okay, now I'm going to go back to my area formula, and I'm going to substitute in my h. So now I have 1/2 the base times the height, and here's an expression for the area in terms of x. Well, the back of the book has something kind of strange. They actually have 2 times 6 minus x times the square root of 3x minus 9. So to check and see whether or not I'm on the right path, I'm going to see if my expression is equivalent to their expression. So here we go. I'm going to distribute the 1/2. Okay, looking good so far. And then I'm going to start simplifying under the radical. Well, if I take the square of this whole deal, then I'm going to square the half, and I'm going to square this binomial. And so if I FOIL this thing out, then I have an expression now. I'm going to distribute the 1/4 through all these, remembering that I'm subtracting, right? So all the signs are going to change. So a negative times a positive is a negative times a negative is a positive, and a negative times a positive is a negative. And lo and behold, all of these little critters are divisible by 4. And now I'm going to combine some like terms. My x squareds go away. I'm going to trade places with these guys so that my negative sign shows up a little easier. And now, because 12 and 36 are both divisible by 4, I'm going to factor that 4 out. But taking the square root of the individual factors allows me to simplify to 2, right, times 6 minus x times the square root of 3x minus 9. Now, the nice part about this form is that it helps to show the domain restrictions. Obviously, if x is 6, then that part goes to 0. And if x is 3, then the square root part goes to 0. So that's going to tell me something about my domain restriction. X has to be greater than 3, right? 3 doesn't work, really, because I get 0 for the area. And 6 doesn't work because I get 0 for the area. And this triangle with 0 as the area doesn't really make good sense, right? Okay, so there's a little hint. And now what you're going to do is we're going to take this function that I have, and we're going to do some things to that function, right? They're going to ask us to do a construction on that function and assume the maximum value of the function occurs when x equals 4. Find the maximum value of z, a of x, and z equals 2a, 3x plus 3 plus 1. So part B, find the maximum value of z equaling a of x when x is 4. So we're just going to substitute x equals 4, and they're saying z equals a of x. Well, that's the area function, and so z is the value of the function when a is 4. So we're going to plug in 4 and evaluate that. And then we're going to have a construction where we take 2 a 3x plus 3 plus 1. So my 3 questions, am I in simplified or standard form? Well, because there's no parentheses in here, I'm in simplified form. So I can take 2a 3x minus a negative 1 plus 1. And now I'm in standard form, right? I factored out the 3. And so here I'm going to BCAD this thing, right? So I'm going to compress, I'm going to shift, I'm going to expand, and I'm going to shift, okay? And I will let you tackle the graph of that thing. And then when they ask you to assess, basically what we're doing is checking out the domain and the range of the new function, right? So obviously the domain is going to be squished down because I've compressed it. I'm going to be moved over towards the y-axis. The range values are going to double, and they're also, everything's going to go up 1. All right, so let's see if you can. I started out with a graph like this. Okay, I'm going to compress, everything goes down. I'm going to shift, everything goes over. I'm going to expand, right? So I'm going to have some graph that's over here somewhere that is a compressed, shifted version of the original. Okay? All right, there's your hint for 13.6. I hope that helps, and I will see you in class tomorrow.